All right, so let's see what we're doing here. We got the radius, 8 meters from the center, and then we know the acceleration, 1.5 g's acceleration. So, okay, so if the riders are 8 meters from the center of the fairground ride and experience 1.5 g's of acceleration, how many radians per second is the ride spinning? So we want to know omega, or radians per second. Also, we want to know revolutions per second, which can be converted from radians per second. So let's go ahead and look at the equations and see what we can do. So again, we have the radius, which is 8 meters. And then we have the acceleration. So 1g is going to be 10 meters per second squared. And if we have 1.5 g's, that's going to be 1.5 10 meters per second squared. So that's going to end up being 15 meters per second squared. Okay, so we have A and R. Let's see what we can do. And we want to find omega. Okay, we have A. We have R. And here we can solve for velocity, but here we can solve for omega, which is what we want. Okay, A equals R omega squared. A equals R omega squared. So the acceleration, we know that, 15 meters per second squared. Actually, let's leave the units out. It'll be simpler. Okay, R is 8 omega squared. Divide both sides by 8. Get out my calculator. (15) divided by 8, and we end up with 1.875 equals omega squared. All right, I'm going to take the square root of this one now. And I end up with 1.37. Omega is plus or minus 1.37. Now, it actually doesn't matter which one you choose. You could say that it's spinning to the left or spinning to the right. Well, it doesn't actually tell us, but I think I'd prefer just the positive. So omega is 1.37 radians per second. Now, what we want to do now is find how many revolutions per second this is. So we gotta multiply this 1.37 radians per second. And we gotta have revolutions. We're trying to convert it to revolutions. So we want revolutions on top, and on bottom we want radians so that they cancel. Now, how many radians is one revolution? Because we want this whole thing to be 1, right? So we put 2 pi radians on bottom. Because 1 revolution is 2 pi radians. Okay, take 1.37 divided by 2 pi. Or here, let's do this. So 1.37 divided by 2 times pi, which let's estimate 3.14, and we get revolutions per second, because remember the radians canceled. Okay, so 2 times 3.14 is 6.28, 1.37 revolutions per 6.28 revolutions per second. And we end up with about 0.218. 0.218 revolutions per second. All right.